Professor Dave and Chegg here. To do science, we must do experiments. And in doing experiments, we must collect data. If we are collecting quantitative data, this means that we are taking measurements of some kind. But how do we know that our measurements are reflective of reality? We must be able to interpret data, so we will need to understand the concepts of precision and uncertainty.
Whenever we take a measurement, we must use an instrument of some kind, and any instrument will provide data that comes with an associated level of precision. Let's say we want to measure the length of an object in centimeters. This ruler displays centimeters, so we could say that this object is between these two centimeter markings, and then we could estimate one more digit beyond that, the tenths place. Now let's say that the ruler also shows tenths of a centimeter. Then we could reliably report our value to the tenths place and now estimate the hundredths place. This is because when taking measurements, we always estimate one digit beyond the scale that is reported on the measuring instrument. The more digits there are in our measurement, the more precise it is. But no matter how precise our measurement, there will always be some uncertainty associated with it. If we measure something as being 2.4 centimeters, that means that it is really somewhere between 2.35 and 2.44, which will round to 2.4, since the tenths place limits the precision of our measurement. Even if it was 2.4187293 centimeters, there is still uncertainty associated with that final digit. The precision associated with measurement is an important concept to understand because we are limited by our five senses in the way we interact with the world, and therefore in how we do science, since analysis of the data we collect is the only way we can do science in the first place. We never want to report data to a higher degree of certainty than is appropriate, so that previous measurement to the tenths place can only be to the tenths place, as there is no way for our eyes to estimate with greater precision than that. We can't report a value to more decimal places than our measuring apparatus will allow. But this concept only applies to measurement. Counting numbers and defined values have infinite precision, like the way there are exactly 12 in a dozen, or exactly 1,000 meters in a kilometer, with no uncertainty of any kind. The precision of measurements will affect the way we do calculations with our data, but these infinitely precise values will not. This is because any uncertainty associated with a certain value must propagate appropriately when doing calculations with that value, and we will learn about this process when we learn about significant figures.
As you can see, precision and uncertainty are important concepts to understand because, as we said, measurement is the way we collect data, and the interpretation of this data is what science is really all about. Professor Dave for Chegg. See you next time.